Next, we will sing a song of national anthem of Indonesia Raya. We kindly ask all the participants to turn on your camera. Ladies and gentlemen, the theme of today's webinar carries significant importance as the infrastructure sector is currently undergoing rapid transformations. This is reflected in the government's massive efforts to accelerate infrastructure development through digitalization. As a result, the need for effective asset management continues to grow. But how we ensure proper asset management so that the infrastructure built can be utilized optimally in smarter ways and provide maximum benefit to Indonesian people? To answer these questions, we are honored to have highly respected expert with us today who will provide deep insight into this topic. Therefore, allow us to welcome Head of Himpunan Pengembangan Jalan Indonesia or HPJI, Dr. Insinyur Hedi Rahadian, MSc. We also welcome General Secretary of Himpunan Pengembangan Jalan Indonesia or HPJI, Insinyur Hedi Rohandi Aga, MSc. General Manager Digital Solution of Ferris from Australia, Mr. Nathan Quadros. Mobile Mapping Director Sales and Business Development of Leica from Switzerland, Mr. Rafael Godard. IEC Solution Engineer Autodesk from Indonesia, Mr. Rangga Taruma Atmaja. Road Asset Management Expert also as the session moderator, Insinyur Novias Nurendra, MSc. And all of the audience members from government ministry and agency, regional office, state-owned enterprises, private sector employee, the public, and university students across Indonesia. We would also like to extend our gratitude to all the sponsors for their contributions to today's event, including PT Hutama Karya Persero, PT Autodesk Indonesia, PT Delta Sistek Indonesia, PT Leica Geosystem, PT Semen Indogreen Indonesia, PT Semen Indogreen Sentosa. Okay, ladies and gentlemen, before we begin the main session of the webinar, please allow me to convey several rules for today's national webinar. Okay, please use the following Zoom username format: name, stretch line agency or instructions or institutions. For example, Radean, stretch line HK. And please do not to turn on your microphone or share your screen or annotate on the screen or perform any other action that might disrupt the event. Participants are expected to fill out the attendance form provided in the chat column and use the official virtual background prepared by the committee. If you wish to ask questions to the speakers, please send them via personal chat to the Q&A account using the format name, search line, agency, or institutions -question. Participants are expected to maintain order throughout the event. Okay, ladies and gentlemen, before we proceed and continue our agenda, let us capture this moment with a virtual group photo. All the speakers, the moderator, and the participant to use the virtual background provided by the committee. And please to turn on your cameras. Okay, we start for 2 times to take a picture together. And let me to count first. Okay, ladies and gentlemen, be ready. 3, 2, 1. Screenshot. Okay, once more. 3, 2, 1. Okay, thank you so much for ladies and gentlemen to joining us for today. And okay, ladies and gentlemen. So let us now move to another sessions. Ladies and gentlemen, let us now listen to the opening remarks for today's event. And committee, please play the video. Okay, we will now hear the opening speech from Insinyur Hedi Rahadian MSc, of Head of Himpunan Pengembangan Jalan Indonesia or HPJI, to Mr. Hedi Rahadian. The floor is yours.
Thank you, Ms. Widya Ayu Pratami, for the time. As the president of the IRDA, I welcome this webinar on road asset management. And also I like to thank all the speakers, Mr. Nathan Quadros, Mr. Rafael Godhard, Mr. Rangga Tarunatmanja, and also Mr. Nufias from Hutama Karya, and also for the sponsors of this event. I believe that road asset management is quite important because Indonesia has more than 400,000 kilometers roads, either under the national government, central government, or the local government. Also now become our concern about the asset management for the toll operator, in which I think Hutama Karya involved a lot in this. Road asset management is not only on the data acquisition system, but importantly is how we can utilize all this management to achieve what we call a kind of the minimum service level at the minimum cost here. And it's quite a challenge because road preservation, for example, is it needs lots of fortune to implement. And I believe that this kind of the webinar will enhance our understanding and also will enhance our implementation, how to get the road asset management in a good way, and how to have a good data through data acquisition system. Now we involve the digital technology, and also how to implement particularly preservation program for these roads to achieve minimum level of service at the minimum cost. So again, thank you very much for all the speakers, the sponsor, and the participants. Thank you. Ms. Widya, please carry on. Thank you.
Okay. Thank you so much, Mr. Hedi, for your remarks and for official opening today's webinar. May Indonesia's road management quality continue to advance with optimal infrastructure asset management. Okay, ladies and gentlemen, now we move to the presentation session, which will be moderated by an expert in road asset management who has already joined us here today. Who is it? Let us watch this short introduction. Okay, our moderator today is Insinyur Novias Nurendra, MSc, an expert in road asset management and a member of the HPJI Expert Council. Mr. Novias has an impressive and wonderful career. From 2020 until 2022, he served as the operational director at PT Hutama Karya Persero. He then continued his leadership journey as the founder and CEO of PT Endurance Challenge Indonesia from 2022 until now. And most recently, in 2024, he was appointed as a commissioner at PT Lapi Ganesha Utama. Wow, what an outstanding and remarkable professional journey. So, what are we waiting for? Please welcome Mr. Novias Nurendra to lead the session.
Thank you to our MC, Ms. Widya Ayu Pratami. First of all, thank you very much, Dr. Insinyur Hadi Rahadiar, MSc, President of the Indonesia Road Development Associations, for the visionary opening speech, which has set a clear direction for us all. You have emphatically highlighted the critical importance of digital transformation in road asset management for building sustainable infrastructure, as well as the Indonesia Road Development Association's strategic role in leading this initiative. A very good afternoon and warm greeting to all distinguished participants of this Indonesian Road Development Association National Webinar. Joining us from across Indonesia, I am Novias Nurendra, and I will be serving as your moderator for today's presentation session. Our team, Digital Solution for Smarter Road Asset Management, is a direct response to the pressing issue we face. The information gap, inaccurate data, and the growing maintenance backlog that threatens our road assets. Today, we will explore practical digital pathway to overcome these challenges. Here is our agenda for the next few hours. We will have 3 main technical presentations, each lasting 30 minutes. Our first speaker will lay the digital foundation by discussing advanced data acquisition and spatial automation through tools like roadside and bridgeside. Our second speaker will then take us into the world of global precision standard for reality capture. Our third speaker will tie it all together by showing how to manage this data throughout the entire infrastructure lifecycle. Following the presentation, we will have an interactive 25-minute live Q&A session with all speakers. We encourage you to submit your question at any time using the Q&A function in your Zoom platform. We'll address as many as we can during the dedicated session. So, without further ado, let's begin our exploration of digital solution. We begin the fundamental question. What do we have and where is it? Accurate visibility is the first step towards smarter management. It's my pleasure to introduce our first speaker, Dr. Nathan Kudrus, General Manager of Digital Solution from Ferris, Australia. Mr. Kudrus is a seasoned leader with extensive experience in driving digital innovation across the surveying and geospatial sector. At Ferris, he is at the helm of delivering integrated digital solutions that transform how infrastructure assets are mapped, monitored, and managed. His expertise is critical in bridging the gap between physical infrastructure and digital world. Please join me in giving a warm welcome to Dr. Nathan Kudrus, who will present on the topic Geospatial Intelligence and Digital Survey for Road Asset Visibility. Committee, please show the bumper. Okay. Mr. Kudrus, very good afternoon in Australia. Thank you for joining us during your day to share your insight with our audience. We are thrilled to have your perspective from Down Under. Before you begin, could you please confirm that you can hear me clearly and ready to share your screen for your presentation, Mr. Kudrus?
Yes, I can. Hopefully it's all working at your end.
So you can share your screen.
Thank you.
Excellent. We can see your screen perfectly. The floor is now yours for the next 30 minutes.
Thank you very much for having me today. It's with great pleasure that I join this webinar with a fine audience. It's really relevant today in Australia, Indonesia, and globally that we start to operate smarter. And I'm lucky enough to work in the digital space around asset management. And my team is a reasonably sizable team and working in the innovation space. And this is sort of a precursor to a little bit of the mobile laser scanning that will be presented later. So as getting into it, this is a little story that I had with what we have a council here in Australia that is local government that looks after an area, and just the value of spatial information and spatial data to support road management. We were working with this person who was running the project, needed to upgrade the road, and as it turns out with the road design, they needed to remove a lot of trees. They were getting a lot of pushback from the community around building this road, and it was really important that they were able to do that. And so he gave us a challenge, and that challenge was to identify the tree roots and the trees that were impacted by the road widening project. And so we used mobile laser scanning, which you can see in the picture here, and 3D radar, which is towed behind the vehicle to below the road surface, to identify where tree roots were. And the fact we were able to identify tree roots, which are the little yellow sort of squiggly lines in the middle of the road towards the bottom, and the areas of the trees which were impacted by the road design, we were able to take that to the community, and they were able to ease that road design and get less pushback through that. Not only that, through this data, they were able to identify only 10 trees being removed at the end of the project, as opposed to hundreds that they thought was going to be beforehand. And this is the value of data. In this particular case, it was good for the environment, good for the community, and it ended up saving a lot of money. And so I think it's a really good story that identifies the value of digital and the value of data. One of the things I work and my team works around AI and automation and analytics, and we integrate that with dashboards and platforms. And I'll present some today in roads and bridges and infrastructure management, with a primary focus on roads and bridges. One of the things before I kick off, I get a lot of questions these days about AI and using artificial intelligence in all sorts of different ways. And I like to say automation is not just AI. AI is one of many tools that we can use. We can use scripting, traditional analytics and geometry to extract things. It's one of many different techniques that certainly enhances it, and we build it in on our tools, but not everything is AI, and AI is not always the best answer for some of these solutions as well. So there's multiple pathways through automation, and that automation is critical in any sort of data or digital solution. When we're talking about, I think it was something like 40 or 400,000 kilometres of roads. It's a lot of roads, a lot of infrastructure. And if you don't automate, you can't scale. And so this is built from high quality data foundations. If you have bad data to begin with, your insights won't be very useful and will be inaccurate. So you have to have good quality data. And then when I say it's not just about technology, it's about the people too. You need to work with the people. You need to co-design the people with people in mind so that it's useful and not just present a technology-based solution. On the images here, this is the level of detail you can get through analytics and AI around that sort of data around sort of from mobile laser scanning. And I'll present a little bit of this as we go. This is a little bit of a strategy piece as a precursor to it. And for us, there's four elements. It's around collecting the data, collecting high quality data efficiently. And then I showed that image before of mobile laser scanning. Holding the data in platform, making sure it's usable rather than just supplying a hard disk which gets lost, or as if another problem. We supply a lot of data and people say, how do I use this data? And can't get the information they want. So we want to make this available on a platform that people can use. Then it's about creating the insights, which is where I like to spend a lot of time, and it's a lot of fun. So that's where you extract the insight. So if you want to know a pothole, or you want to know rutting, or you want to know cracking, how can we do that? And ultimately delivering that value back to someone who needs to go manage and maintain that road. So this is a little bit about my team and the way I run our team. There's two elements to it. One is around the digital solution and the technology, and that's the element I run within our business as GM for Digital Solutions. There's also a consulting and advisory business, and that's around the expertise. So the consultants and the expertise around there. We're digital consultants, not necessarily the road management consultants and others that understand that domain. And you need to work together. If you're not working together, you'll present a digital solution that won't be relevant around that. For our digital process, it's around this data capture, and then you have to have the ingestion, the storage, and where I spend most of the time and where my team spends is in this automation space, through to pushing whatever you're automating back into a database, a platform that people can use, and ultimately a report that can be provided and interpreted. And so that's the methodology we try to push through. We've got a number of solutions, and I'm just going to talk about those to do today and around roadside, bridge side, and photo navigator that I think is hugely relevant to running road networks. So if we start with roadside, we know that stopping by the road is inherently unsafe. It can be costly having crews out there all the time. There are mistakes made, not deliberately or anything like that, but just through human interpretation. And so this is around using mobile laser scanning, which is a combination of the laser scanning, directional cameras on board the vehicle, and 360 cameras like you get in Google Street View, using them all to get a better picture of the road. And this isn't using just one data source, it's using a fully integrated data source, all available through the platform, so the best data source possible to get the best insights to manage those roads better. And so I'll take you on some examples of how we do that and how that's saving time and efficiency and bringing in more detail. Now, there's a number of camera-based solutions out there. They're really good, the dashboard-based camera ones, but they often don't bring the metrics that you'll see available through a combined solution with laser scanning that you can get of roads and infrastructure. So this is a detail where we've got a little bit of a pavement failure along one of the roads here. And if we're able to run our analytics along it, we get these red areas where there's a depression in a spot of a road like this. If you're able to present a contour in millimeters of this road at various threshold values, then you can start to understand with the amount of detail here around what that pavement failure looks like and whether that's an actionable decision. With a lot of our road maintenance contracts, they're action based on a depth or some sort of requirement around a pothole or rutting, for instance. So we can see if it breaches the threshold, in which case the centre here is turned amber against that threshold, which means something in terms of the road maintenance provider. So that's the level of detail you can get to. Here's the -12 represents a -12 millimeters in depth. And so you can get all those statistics and you can start to rank them by the terms of severity of those various defects on the road. One of the advantages of the solution and we focus on the automation is that we don't have a set kind of view of the software or the dashboard. So we build a custom-based dashboard with the information that is needed to manage that road at that time. So you don't get an off-the-shelf sort of one. We work with the providers around what they want to see in it. So this particular client wanted to see the severity of those impacts. And you'll see the look and feel of this change. This was for a different client that we were working with that was looking at the road network, and wanted to know the areas and severity scores of those various networks. So they wanted a much simpler piece, and so we've got the metrics there, and we get a scores against things like cracking, rutting, corrugation, pothole. This is all automatically generated from the mobile laser scan data, and you can start to see this across here. And I'll give an example of the platform soon, but it's only having it in the map view and then also having it in the kind of street view kind of look as well. Not only is it available for sealed roads, then we've got the unsealed roads in this particular instance. So technologies like 3D radar are able to look below and start to get the idea of gravel depth. So in this particular instance, we were topping up gravel depth bolus across all the network. By measuring the gravel depth, we could identify areas which hadn't had any depletion of gravel and were already at that requirement, so they didn't need to be topped up. So we could focus on the areas to topping up gravel in unsealed roads in the areas that were actually missing it. And so here, these sections are green, they're fine. Amber needs a bit more, and then another green area here. And this is a little bit on crack detection. You can see some of these here where you've got images. This is where AI is really useful. AI is really good for image-based analysis. You can start to identify cracks here in this, but not only there's often people in technology is will identify cracks in a road and then supply an image full of the crack analysis, but that's not all that useful. What you need to be able to do is take those images and place them in 3D coordinates over a map so you can actually see where those cracks are in an integrated data set in a platform. So for instance, here you can see the crack analysis, and I'll show you a little bit of that in a second. This is from the image of the roadside that we get. So where there's a 360 camera that looks around the road and can look to the road edges. In this particular example here, we were doing vegetation analysis of that. So every 10 meters along, we get AI to analyze those images and then classify that vegetation in terms of conservation value. So in this particular instance, the client wanted to upgrade the conservation value of this road. So they wanted to know which was the lower conservation value so that they needed to plant more trees and these sorts of things. And we were able to use sort of AI descriptions to go fill this out over hundreds of kilometers of roads. Another example of where digital technology is really useful, and I really love this one because it uses spatial data and coordinates, and there's a bit of complexity. I won't go into that. But the top view, you get a map view of where these defects are. But one of the things we wanted to do is it's not just enough to see where the defects are. We want to overlay it on the actual photo that was taken of the road. So we can take these defects here and reproject it into the photo, into 3D space of that photo, so that people can pan and zoom around and see where those defects are against those particular areas. And you can end up switching them on and off to see a pothole or a rutting below that. And that's the advantage of a laser scan. Not only in a photo-based solution, you will just get a bounding box around it, but with a laser scan, you can actually tell the metrics of the depths and those sorts of things. One other example here is then we've got the point cloud, and we overlay the point cloud of a crack, and we start to classify that crack as transverse. We can get descriptions of those cracks and those sorts of things. So again, another example of it. And this is not just done in Australia. This is done overseas. We worked with Hexagon on a particular project in the Middle East or in UAE, where they sent us some data, and we were able to then run the crack detection on this, and there's tiny little cracks here, to see the cracks along the road and then project it back into that map surface. So here's a little bit of a video of roadside and the potential of digital in this space, which sums up what I've been talking about. As you know, traditional inspections are fairly labour intensive. They're often unsafe. A lot of environments are very difficult to get to. Something like mobile laser scanning, you can see on the top of the vehicle here. It's got the mobile laser scanner and it's got the 3D GPR that's sitting behind it. That can be driving the road, picking up all that data very efficiently, very quickly without stopping. You can do surface deviation en masse in a lot of these areas of roads, and you can start to look at the areas which have the most critical concerns associated with it. And so diving into that level of detail around those defects, such as rutting, potholes and cracking in a lot of detail, is really important for that management of those roads. You can also look at other things there like white lines and road width analysis and other bits and pieces. But then I was talking about the context, bringing in the imagery, the street view type look of it, to go understand the context of what's actually happening. it's being able to drill deeper. So if you get a PDF of something like this, you're not able to drill deeper in it. It's pretty limited what you can do and what you can read. Having it in a digital platform enables you to manage both on scale, but also dive down into a lot of detail. Here's a little bit on unsealed roads and looking at gravel depth, where we're able to analyze that. But again, it's going back to the image to identify these areas where gravel might be missing and zoom around and see what's actually happening at that site. So this is the data that I showed before around that was sent to us from the Middle East, and we're able to do the analysis. And if we blow up this particular area here where the cracks were located, you can see the evidence of it there. So, but it's being able to scale that automation en masse where the benefit really is. So this is most of the ability around our roadside solution. We've got some other case studies here. At the very start, I talked about the council, and this was a presentation we were able to do back to the community around the vegetation that was impacted in this road widening project, and to identify which vegetation would be impacted by the road widening itself, so people could know what's happening to the trees outside the front of their house or their home or their property, so that they knew what was happening. Some of the key benefits, and you can see here the point cloud in the background that is provided by LaserScan and the level of detail. It's a large volume of data. You need a lot of capability to be able to analyze that en masse, but then you can get much deeper insights and start to extract things like road signs, guardrails, vegetation encroachment, all these sorts of things. So you've got a complete asset map at one pass, not only the pavement condition, you've got those assets there, you've got vegetation encroachment and potentially road safety as well. So we conducted this, what a platform called Roadside. We did it around a mining area here, and we were able to provide that level of detail where the company in this particular instance gave us a 9 out of 10 and said exactly what we need to understand the state of our roads. So it's about scalable automation when you get in digital. You just don't want to do it on a local area. It's about automating at those larger scales. You're getting the high detail from mobile mapping. Complex structures to analyze and very difficult to understand the state of bridges, and you need a lot of expertise around the engineers there. So we're starting to use UAV technology and other mobile technology around this to capture the state of bridges and then combine that with AI and analytics. So if you look at something like a drone survey here, all these little blue dots are drone images, you can go create or reconstruct a 3D model of that bridge. And so here we were able to construct a 3D model of a particular bridge. You can see the bridge there on the left and the photo taken on the right of this UAV image. Part of the management of it is being able to understand the structure of the bridge. And so really important when we do this is that we create what's known as a level of detail 150 model. It's got a model of the main components of the bridge so that when you have the defects or other such things, and you would typically do this in a PDF report rather than presenting a report, you can attach all the defects and anything you see to the actual BIM model of the structure itself, and then you can start to report by element. So not only is it about visualizing it, it's being able to create a report that's working in current systems, and that could be something like a PDF that's spat out, but you know it's been digitally generated. And so if there are changes to that, you can make those changes, and particularly changes over time. Here we've got an analysis of which areas of the bridge were covered, which areas were gaps. Those white areas there in the mesh model were not covered adequately in the mesh. So we can get some quality scores and quality indexes around when these are generated. And then I love this bit. This is the bit of sort of AI. We can start to search these models around what is actually located. So here I searched this bridge for graffiti, and it's able to identify graffiti on the bridge by a probability. So a red triangle indicates a high probability, a yellow triangle is a moderate probability of that being graffiti. And you can see how well aligned it is here. For the bridge that I was showing you before, I had typed in spalling, and we're able to find the spalling and be able to locate this. And then we call this an AI guided search. AI is still in its infancy in some of these ways and still has a long way to go. It's not as reliable enough, but it can guide an engineer to the locations they need to look at much more smartly and much more efficiently than just purely trying to search these features. One of the things that is a little bit different is crack detection. So using these images here that are taken by the drone in this instance, you can start to map these cracks features back on the bridge model. And that's using a combination of that sort of 3D projection piece. And then you've got all this sort of basic thing. This is just taking a measurement around this sort of drainage and starting to enter this in when you're trying to do your digital inspection. So you can add your digital inspection all through these, filling out drop boxes and little text boxes. That then gets fed into a report that is generated at the end. And so it's all linked together. The visual is linked together with the inspection, which is linked to the report, rather than looking in one platform and trying to fill out an Excel spreadsheet and trying to fill out a Word document and take some notes. You've got it all together in one package. Ultimately, the road bridge maintenance authorities want a table like this at the end. So this has things like quantities, what issues are found, and all these sorts of things. You're all tracked through this. And if you click on one of those features, you can get a visual which you can understand the context of it, and you can start to get that report back in. So here's a little bit of the bridge side video here. Just a quick question. Can you hear the audio there or not? Because otherwise I'll talk to it. This is the only video with audio.
We cannot you cannot hear your voice or video from video.
Okay, no problems. I'll talk to it as well. This is the bit where I was talking about AI on the video. So here I typed in the word stain, which is leading to a water stain, and it's able to find those particular pieces on this bridge itself. So this is where I talk about the AI guided inspection as well, where the engineers led to places of focus. It's about linking the whole workflow together and not having disparate pieces all over going from one software necessarily to another. In this particular app, it's about keeping it updated over time too. So if someone goes in a field, they can take a photo and upload it to the database. And that way you can know how things are changing because you've got the baseline that was originally captured. And so what you saw there is really around virtual inspections, transferring some of this from a physical inspection to a virtual inspection piece. Really relevant for areas that are highly complex bridges, remote bridges that are difficult to get to, or anywhere you need a lot of equipment around it, like elevated work platforms, barges and other sorts of things. Drone technology and the likes are coming along a long way. AI-enhanced detection is getting far more popular in this space. is far more relevant and far more useful than it used to be, and making that flexible enough that the engineer can search for what they are after. So a lot of AI models are really well trained for one thing, but can't be flexible or on a broad range of things. So the AI, say, for instance, we've built, you can search for a number of features on that bridge. You could even search for wood or the color blue or different sorts of things in there, and it would locate some things around that. And ultimately, it's about prolonging the asset life of these assets. So you're reducing the asset cost over its lifetime. And the last solution I want to talk about is Photo Navigator. And so this was really built out of realizing mobilizer scanning is not for everyone. And sometimes you just want photos are enough. So that's both 360-degree photos, so the street view type photos, and the straight directional photos, whether it's from a smartphone or whether it's from a digital SLR or other sorts of sources. You can then combine that together to give people a quick view of a site so that they don't need to visit that necessarily physically to go find out what's there. So this is a project we've got at the moment. You can see here we've driven all the lanes of this freeway and we've got photos. We generate these photos every 5 meters, but we can do it every 20 centimeters if we want. It's a bit of overkill to do that. You've got a range of assets that are located in here, but you can visit any of these sites virtually by clicking on any of these images. We've got a number of photos here in green, and the blue photos are others that have been generated by people walking around with flat stills and things like that to do virtual inspections. You then got descriptions of what occurs in that, which you can use for reporting. So here's a little bit on Photo Navigator, which is, again, just a simpler solution for these sorts of things. And it's 360 cameras. You can get everything from very cheap, well, not very cheap, for a company-wide cheap, and that would be sort of Australian, probably about $500 Australian, to up to very expensive cameras in the tens of thousands of dollars, which we're using on vehicles and some of the high-resolution ones. But these cameras here are very, very affordable in terms of getting 360. It's just a less amount of detail based on the camera that they've got involved in there and the quality of imagery. So here you've got the likes of green images that were driven by vehicles. So they load up here and you can pan and zoom around. And then we've got flat images that are gathered by people walking the footpath. So we've got people walking along and you can take these images here and you can use AI, as you can see on the left there, describes what's actually happening in this. If any potholes or cracking are evidence and things like this, you can get those descriptions and start to highlight areas which might be of concern. The good thing about digital platforms is it really enhances collaboration. So if someone takes a note here, they can share it with everyone else who has the platform. So if there's an area of concern, they can type that in and others can have access to it. This is another area around the Middle East where we ran some data and built out the Photo Navigator platform from the data that was captured there. And so that's quite quick and easy to do, but you can build a whole range of functionality over the top of this. Again, it's just got a little bit more around the notes and bits and pieces around it. We're also loading in assets at the moment so you can get a report by asset type in this sort of thing, and therefore save a lot of time. Particularly one recent project we've got, which I'll show you in a second, had 150 reports which needed to be generated. We saved an extraordinary amount of time by automating a huge amount of that reporting straight out of the platform using a combination of the images and AI. So here's a project that we've been running that I showed you before, and we're able to take all the images here that are gathered through helicopters, boats, drones, vehicles, and pedestrians, because you often need multimodal ways of capturing these sorts of things. You're able to do rapid mobilization and then push this out through an AI assisted to generate these reports that have to be provided on handover of that to the asset owner to making sure everything's in good condition. And really, it's around, this is a simplicity around virtual access to that environment. So you don't have to go out there yourself. You can go visit that on site, and that's timestamped as opposed to Google where you log in. This is timestamped to that particular period where you need to access it and need to know the exact conditions at that point in time. It leads to faster reviews and faster approvals of pushing this data out, and the AI tagging has that actual context associated with it. So here's a bit, I thought it'd be useful to show you sort of an end-to-end kind of digital workflow. So this is really useful. You've got the data capture around something like mobile scanning, which sits on top of the vehicle here. Then you've got the data processing piece, which is a complex piece to really know how to process spatial data to get things like the point clouds, 3D mesh, to get a BIM model and various other things out of that. Once you've got that processed, it comes into data hosting. So we like to host the data straight away after processing so that we can get people starting to use it, but you still need to go through the feature extraction process. So we use some of Hexagon's software to do it, Map Enterprise and Luciad, and then have spatial databases in beside it, but you can use a range of software to potentially do your data hosting. Then it's around feature extraction. So it's a combination of AI from the image. You might have spatial analytics from the geometry of things like the point clouds and the mobile laser scanning to automation and scripting. Enabling the virtual inspections so the user can then use a dashboard to go mark that up, use the inspection and what the AI and analytics has seen to then provide the insights to it, and ultimately generating PDFs, Excel, or if you want to go full connection into an asset management system so that enable the reporting and decision making through that whole process. So what the benefit of this, and it's really around shifting from reactive to proactive maintenance. Proactive maintenance is much less costly than reactive maintenance. And so a lot of the goals of just clients I've been talking to, and maybe it's a fictitious goal, but moving from 90% proactive maintenance to 10% reactive. At the moment, a lot around 60-40, 70-30 splits around that. But if they can have more proactive maintenance, they'll be able to plan for that, budget for it, and do it in a more sequenced way, which will lower cost, rather than getting out there desperately at the last minute where costs are inflated. And so if you know the state of your roads or the state of the assets, you can be much more proactive about it. And as you start to get a series of data over time, you can start to predict that. So if it cracks this long 1 year and it grows by 10 centimeters the next year, you can start to do some prediction around how that crack length or width might be changing. Similarly with potholes, pothole surface area and depth. So it's around using that and some of the physical insights around that predictability. So it's being able to do this and visualize at scale and automate the detection and being able to do that, and then ultimately reduce that spending in terms of and increasing the longevity of those assets. And that's it from me. Thank you very much for having me talk. I'll talk later on the panel, but I hope you appreciated the insights I've presented today. Thank you.
Thank you, Dr. Boudros, for the excellent and highly practical presentation. You have clearly demonstrated how spatial automation with tools like roadside and bridgeside using 3D radar and mobile lidar can create a powerful digital foundation, not just for a road, but even for complex tasks like mapping tree routes to preserve the environment. A quick bringing question based on your presentation. We saw how automation goes beyond AI to include role-based workflow. From your experience, what is the most significant operational change an agency needs to make a fully benefit from this kind of spatial automation?
There's so much to go on that.
Just 1 minute. 1 minute.
Yeah, I would start at the very foundations of data and digital literacy. So I know it's the people element. It's very easy to talk about the technology, but people need to understand the value of data and digital. You can build all the tools you want in the world, but if people don't understand the value of it or too scared to use it, it'll be almost useless. So we're trying to level people up and work with people who really know their data and digital literacy or really inclined to learn more about it. And then you'll have a faster take up, because if people don't have that at the foundation, you're not building technology that people will use. So I know it's not the technology answer, but I would focus on people.
Okay, that's great. A crucial point here for adapting processes, not just adapting technology. Thank you, Dr. Boudros.
No problem.
Now we have seen how to acquire rich, actionable data. But for this data to be truly reliable and trusted for major decisions like prioritizing maintenance and allocating budget based on precise indicator like International Roughness Index and Pavement Condition Index, we must ask how accurate is it, and does it meet with the global standard required for the long-term investment and planning? This leads us to our second speakers. Let's welcome Mr. Rafael Godard, Mobile Mapping Director for Sales and Business Development from Leica Geosystems Switzerland. But I heard Mr. Rafael Godard now in China. Rafael is a renowned expert in geospatial field with a deep specialization in mobile mapping solutions, MMS, and their application across large-scale infrastructure projects. His work at Leica, a global leader in measurement technology, involves setting the benchmark for precision and efficiency and reality capture, which is critical for overcoming the challenge of limited digital technology adoption in road management. Please give a big welcome to Mr. Rafael Godard, who will present on precision reality capture global standard for smart road asset monitoring. Okay, Mr. Godard, a very good afternoon to you in China now, yeah, not in Switzerland, yeah. I hope the weather is pleasant there.
Good afternoon. Can you
we
hear
truly
me okay?
appreciate your joining us and bringing the renowned Swiss precision to our discussion today. Can you hear us well, Mr. Godard?
I can hear you very well, but I am not sure you hear me well. Can you hear me well?
I hear you well also here.
Excellent.
Okay.
Excellent. So let me start.
If so, please feel free to share your screen to begin your presentation.
Yes. Let's go ahead. I don't know if you see my screen already.
Yeah, not yet.
One second.
Take your time. You're waiting.
Yes. Okay. Do you see my screen now?
Yes, perfect. We can see your screen now. So the next 30 minutes are all yours. Please.
Excellent. 1 second, I just need to set the last thing that will help me in this presentation. Hello, you still see my screen, right? All good.
Yes, we still see your screen.
Perfect. Hello everyone. I'm thrilled really to join this session. I'm also very grateful for the invitation. I must say it's a great honor to share insights from a supplier like Geosystems, part of Hexagon, as you know, is a supplier of solutions for this market dedicated to road asset management. And I'm also very happy to pass just after Nathan Quadros, who I know very well. I had the pleasure to meet him in Australia during my last trip there. So I'm profiting of this session to say hello to him. And I'm also happy because I will share some examples that we did together for a very important project in Germany, but this will be part of my presentation. So please stay tuned. So what are we going to cover today? First, I would like to set the stage more starting with a why, and then a how and a what, going through the key challenges, how we are measuring, what we are offering here at Hexagon and Leica Geosystems for measuring, and then how we can scale these measurement solutions for the pavement condition. In the second part, I would like to share with you how we are approaching in practical terms, how we are capturing data, how is the process to go from the field to the finish to get the final results for the pavement analytics. And I will end this session by sharing with you 2 case studies we had the pleasure to participate in and which are, I guess, very insightful, very relevant for these pavement activities. So let's get started and let's answer the question, Why? Why tackling the key challenges with road asset management systems, where they, as you know, the roads are or arteries of our cities, and when they are healthy and smooth, everything flow. We are all fine, people are good, and services are running well. But when they deteriorate, the entire system feels the impact. So we have issues with safety, we have higher costs, and also wasting time. So why do we need these road asset management systems? First, we need, as fast as possible, real-time data collections to close the gap for decision-making. So it's really important, and I'm also glad that Nathan underlined that during his presentation, showing the relevance of capturing data efficiently and fastly. Second is about predictive and condition-based planning, which helps, and also the asset value loss. Then we have the financial part. We need to have data-driven financial planning that really ensures optimal uses of the resources. The integrated and collaborative approach, and the software or the solution that was presented by Veris just before is a perfect example of this, right? Having a collaborative platform where every data is stored and shareable among the different stakeholders is key. And I think that was a very good example for that. Then, of course, we need to consider that this needs to be scalable. We are talking about huge amount of data. We are talking about hundreds of thousands, or maybe sometimes for some countries, millions of kilometers of roads. And that requires a very solid system to be used. So now that we have answered why we need these RAMs, I would like to answer another important question, which is how such data volume can be collected. And here at Hexagon and Lake Ariel System, we have this saying, which I like very much: from micron to Mars, we measure what matters, which means that within our company, we have the solution for whatever the challenge is when it comes to measure the Earth. And I'm sure you are aware that within our company, we have very different sensors able to tackle these different challenges. From the very large scale solution where we are using airborne capturing with LiDAR, with imagery, or with combination of both, but also mobile mapping, which are used mostly on all the infrastructures that are accessible with a vehicle. But also we have the terrestrial laser scanner. And here you see that depending on the scale, but also depending on the accuracy, we have a solution that will fit the need of our customers and our stakeholders. So the process is very straightforward. We are talking about capturing the information, preparing the information, and then delivering it. So here are some different solutions that in real, so that you can figure out what we are talking about. The city mapper or the terrain mapper that are used by the airborne team, the airborne mapping solutions. We have the Pegasus TRK, and I will give more insights about this solution, of course, because this is my domain in the next part of this presentation. The terrestrial laser scanning, and also the solutions that are mobile, which can be portable by hand. And finally, and which is also very important, we have also solutions that help to map the underground. So capturing everything below the ground as it were. In one go. So here is the mobile mapping solution family, the different products that we have launched since, I would say, a certain amount of time. We started mobile mapping more than 10 years ago. I'm talking more about 2011 when we started. And this is now the latest generation of the famous Pegasus mobile mapping solution. And I will give more details afterwards. The next questions I would like to answer now is what road asset management system challenges mobile mapping can help solving today. And it is a matter of fact that in every country, there is a huge network of roads, from high speed to local roads within the cities. Every category of road plays a critical role in keeping the country moving. But maintaining such an extensive network is not simple. It requires an extensive network. Maintaining such an extensive network is not simple. It requires accurate monitoring and early detection of issues. So we have different indicators that are used to, I would say, define, and this is, of course, something you know very well. The three main that are defining the quality of the roads are the IRI, the International Roughness Index, the PCI, the Pavement Condition Index, and the routing analysis. IRI tells us how smooth or rough the road, and PCI gives an overall score for the pavement, while routing looks at all the deviations for the wheel paths, which can be affected. And detecting these elements efficiently and in advance will help for the road maintenance. So, have you ever wondered, and I'm sure maybe you have some souvenir or memories on how it was done before? It was a very manual way, and I took this picture to be a bit provocative. This is a system that shows how roughness was measured with dedicated mechanical optical devices before modern sensors. So we can easily imagine that this was taking a huge amount of time, and you could not cover a lot of distance with such a solution. The second image is a condition survey sheet, which every inspector had to fill. So we are talking about a non-digital world, a complete world with paper, a non-future-proof world. And that's where we started, and now we need to move on. So what could be the advantage of using mobile mapping solutions, and how can it help to the road asset management solutions? First, it's clear that we can accurately and very quickly collect information. Today, we can capture hundreds of kilometers in one day, and that vast amount of information can be also treated mostly in real time, and this speed and precision empower to make better decisions. Then we have the exhaustivity of the data. Mobile mapping is able to capture the pavement by itself, but also all the assets that are around, the road signs, the traffic lights, but also all the buildings and the elements that can be relevant for any kind of analytics. It is also a very efficient and cost saving. As I say, we can capture 100 kilometers per day. It has a very simple processing workflow. It is true that initially this technology was quite addressed by very skilled and very knowledgeable people. But now with the latest generation of the solutions we are providing at Lake Agile System, this technology is accessible by the huge number. So it's very easy to learn how to capture and process data, which means the data are putting to work very quickly. And this helps for sure to democratize the access, as it was shown in the previous presentation, having a 360 pictures environment where the user can navigate efficiently, having the capacity to load the point cloud in this environment, making some measurements, loading some report, extracting some information. This is a very efficient way to consume the data, and I'm very happy that we are participating in this journey with this solution. Let me touch now the second part of my presentation, which is from field to finish. And here I really wanted to give you a practical view of how it works with our solution. First, as I mentioned earlier, we have a family of different products. The name is Pegasus TRK, and you see that we have different kind of Pegasus TRK, and I will give a word about that. This solution has been built on a very powerful concept, which lays into 3 words: simplicity, intelligence, and autonomy. We wanted this solution to be usable in a most efficient way. And that's why we have also the same positioning sensors across all the variants. Whichever solutions you could work with, it has exactly the same GNSS, the same AMU performances. And also the software is unified. Whatever solution you will use is exactly the same software on the field or in the office. About the family by itself, we have the mid-range solution, which are the TRK 100 and TRK 300s. They are ideal for routine and road surveys. The TRK 100 is lightweight and great for urban areas, while the TRK 300 offers extended range for longer road corridors. But then for high-end application, we move more to the TRK EVO and NEO systems. They are available in single or dual LiDAR configurations, but these deliver ultra high point densities and accuracy. And this is, from my perspective, essentials when it comes to detect cracks, when it comes to detect routing or surface irregularities. So in short, as a summary for this slide, TRK 100 and 300, perfect for standard surveys, but then EVO and NEO are the most recommended solutions for the pavement condition assessment. So maybe you were wondering, what is the workflow? As I mentioned before, with the different sensors we have, it's relays in 3 steps: capture, prepare, deliver. So it's quite straightforward. But we can capture and process data also in real time. That's something that is unique with our solutions. If you are activating the real-time kinematic, you can process right after the mission the project on site, which can be beneficial for various applications. Of course, you can choose to process everything in the office, and then it comes to I would say standard workflow to reach the maximum accuracy possible. But then you see there is this big question mark for the delivering part, because there are a lot to say here.
Hello, Rafael. Can the committee help Dr. Rafael Godard to back to the session?
Hello. Hello, hello. Can you hear me?
Yeah, I'm hear you. Just lost a little bit. Now I'm see you.
Yeah. Okay, sorry, I apologize. I think the connection was broken in the middle.
Okay, you can share your screen again.
Yes, let me do it again. And I think, do you see the screen?
Yes, great.
Very good. All right. So I don't know where I was stopped. Exactly. So I was just mentioning that we have a lot of different solutions that are used for deliver. And of course, there are solutions that were just presented before me, roadside from Veris. So I'm happy that it's connecting a bit the loop. But you see that there are many, many other solutions, and we will present some examples today. So let's start with the capture of the data. And here it's quite straightforward. And you will see during, I hope the video will run smoothly, but you will see that it's a very easy installation. One person operation. So it's a light system. here we have a TRK 500 Neo, which can be installed by one person only. And we have a rotating tilting platform, which allows to install on a more convenient way, so that there is no difficulty to install it. And then the acquisition is done from the car with a direct connection with a tablet. And you see live all the information of your data capture, which is the point cloud, but also the position of the car on the map, which is also the pattern, the accuracy of the positioning, and all the cameras that are used for the capturing part. Maybe you do not see that clearly on the video, but we have the capacity to add up to 8 cameras on the system, in addition to the 360 camera, enlarging the capacity of the system. Then it comes the processing and the visualization and the QA, QC of the data, everything that needs to be ready for the next round. So the next round is about, as I mentioned, the preparation of the trajectory, the calculation of the data. And I would like to share with you some very powerful concept we have developed for the cloud to cloud. And here we have a very good example that is used. We have captured this road in different directions of the scanners, and I hope it will be clear on the screen because it shows you the different passes we have operated with the system. And in the end, we have a layer of the street which is close to a few millimeters. This road was captured also with a tunnel, and we have extracted a portion of this tunnel just to show you what were the results between the 6 different passes. We are really talking about multiple passes done in this tunnel, and we were below the 7 millimeter in terms of differences for this tunnel. So tunnel is also a very challenging environment, and this is part of the assets that we are able to capture efficiently and accurately from the system. There is just a mistake. This image are from the, oh, it's okay, perfect. So let's focus now on the pavement analysis, and I will just take an example. I mentioned roadside, Veris was mentioned in the previous presentation, but here I would like to show you another workflow that our customers are also using, which is with the software named Topodot. So again, we are capturing the data with the Pegasus, preparing the data with Pegasus Office, and then we go through the different pavement condition index or IRI or routing. And how does it work? So let's start with the pavement condition index. Here we are loading directly our information into the software, and the software is running some automatic extraction. As it is not AI, it is really analytics of the point cloud itself. So it's very important to have a very clean and dense point cloud to make this analytics, which is why we are very strong offering our solution for this application. And then you get some reports, which can, in this case, Excel file, but can be used afterwards for any sharing with any stakeholders. Another part of the routing and examples of the routing that you can see here with the report as well. And the IRI. So IRI is a new feature that has been developed by Topodot. It was not existing 1 year ago, but they consider that it is an important market, and they wanted to prove that they were able to process this IRI precisely. And they compare the results with a very well-known solution for the IRI calculation, which is Pruval. So they extracted their results out of different data sets we provided to them, and they compare with the Pruval results. And the results was that the comparison was matching perfectly. So for them, it was the conclusion that the tool is working well. And since then, we have a lot of customers that have been working with Topodot and integrating this solution. Here you see, I don't know if the video will play smoothly, but here you see the suspension of the wheels and the results with the different colorization of the IRI based on the extraction that was done. So easy workflow from the capturing, processing, preparing, and delivering part. Now I'm reaching out the last part of my session, and I'm very glad to share with you two use cases that we have the pleasure to work for. The first is a conference that happens every year. It's the European Road Profile User Group. It is part of an initiative that is performed as well in the United States, so it's also a very important event. And last year, there was tests that was launched to benchmark different solutions. And we participated in these tests, and here what it is. So this I would say, road profile user group has been established in 2012, and it's brings together the road owners, the data providers, the researchers, to focus on road condition and surface profiling. And it was really a challenge for them. They wanted to evaluate different solutions because until 2023, the solutions that were used a lot for this kind of analytics are laser crack measurement systems, but it requires some very big hardware, and they wanted to evaluate if we could not use different solutions for this kind of application. That's why they launched this test, Durabast, in 2024. So the purpose of this test was to capture with very different solutions, profiler, mobile mapping, and also connected vehicles, a site that is used for calibration in Germany, which is renowned and used for this purpose. And that's, you see here the different solutions that were used for this test. So we have all the profilers that were used and all the mobile mapping. So we have, of course, different providers of mobile mapping solutions that were used for this test. And in our case, we participated together with Roadside. So we captured all the information with the TRK 700 EVO, and we provided all this information to Roadside team, to Nathan Quadro's team, and they extracted information, which we returned back to Durabast team for the evaluation. So here you see an example of the site that has been captured by the TRK. So here, this is the navigation to the 360 images and also the capacity to switch to the side camera. The point cloud has been classified. So this is an artificial intelligence algorithm that we are using to set the point cloud into different classes, helping to focus only on some classes that are relevant for our extractions. And here you have a fly through, which I hope is smooth enough on your screen as well. So the conclusion of this test was extremely positive because, as you can see in green, the mobile mapping presented the highest repeatability and the best results for most of the different elements that had to be extracted. Of course, we were not the best everywhere, but we are covering a lot of the main parameters that define the pavement condition. And that was a very good finding, a very important finding for this community, because it was the proof that now mobile mapping can be used efficiently for this activity. And as I remind you, it's not only about capturing the pavement, but also all the assets around. The second use case is, I would say, in a way, a bit similar, because this topic of pavement analytics is extremely important in a lot of regions. And we had the chance to perform exactly the same test in Hungary. So in this case, the project was initiated by MKIF. So they wanted to check repeatable and reliability of different systems for pavement condition measurements. So the motivation was to evaluate how mobile mapping can, as a promising solution, can bring efficient information. So the idea was to test different solutions. So having different products from the market, and the conclusion that it would be valid for this application. So different mobile mapping devices were used for this project. in total 3 advanced mobile mapping solutions. There was, of course, a reference system comparison. So every of the 3 were compared to this reference. And we extracted the key parameters for this project, IRI, routing, and also the PCI. And then a comparative performance analysis was performed out of the 3 different captures that were done to get to know which one was the best. So in this case, we used the combination of the Pegasus TRK700 Evo and the software Topodot. We captured the site, so there were many different locations to capture, very different speed also to evaluate which could be the best speed for this capture, from 30 km to 105 km per hour. You can imagine that if the results are good with this speed, you can capture a lot in one day. Then how fast the data processing could go with the different solutions and how accurate and repeatable these results would be. So the results of this test, and that was also a good confirmation that we are on track. We have tested all the MMS, but we showed the best performance with a very reliable repeatability across the multiple evaluations. It was important to understand that a system with a good calibration brought the best results. And as I say, the future development and focus is that now this MKIF, and I think, as I believe, other players will decide to move to this mobile mapping technology for their pavement condition. That's really it for the end of, I'm reaching now the end of my presentation. I like to finish usually my presentation with this quote from Abraham Lincoln: the best way to predict the future is to create it. We have a lot of different articles that you could reach out or find on our website. So I'm inviting you to enrich your knowledge with the different solutions we have, different articles we have written so far. And I will be extremely happy to answer your questions afterwards. Thank you very much for your attention. I apologize again for the cuts during the presentation, and please reach out to us or to me if you have any questions. Thank you.
Thank you, Mr. Rafael Godard, for that masterclass in precision and global standards. From Micron to Mars, that's a cool tagline, yeah. You have shown us how mobile mapping solutions provide the rigorous standardized data for pavement condition analysis, moving us far beyond traditional inspection method. The international case studies like the one from Hungary, I think, really underscore the value of this accurate data for creating reliable digital twins. So now we have precise and standard compliant digital presentation of our asset. I think for the questions we will collect in the final Q&A sessions. The final and critical question is, how do we connect, manage, and use this intelligent data across the entire asset lifecycle to prevent information loss and ensure its value is realized from planning through design and construction, all the way to operation. To connect all these dots, I'm delighted to introduce our third speaker, Mr. Rangga Taruna Atmaja, AEC Solution Engineer from Autodesk Solution. By the way, Mr. Rafael Godard, could you please stop sharing your screen? Okay, thank you.
All right. Thank you, Pak Novian.
Yeah.
Should I share my screen?
Yeah. To connect all this
Okay.
dot, I'm delighted to introduce our third speaker, Mr. Rangga Taruna Atmaja, AEC Solution Engineer from Autodesk Indonesia.
Okay.
Mr. Rangga is an expert in building information modeling, BIM, and digital construction workflow. His role at Autodesk involved helping infrastructure professionals in Indonesia and the region leverage connected platforms like the Autodesk Construction Cloud and the AEC Collection to streamline project from conception to operation, ensuring that valuable information is not lost at any stage and mitigating the high financial impact of data loss. Please welcome Mr. Rangga Taruna Atmaja, who will present on enabling the full life cycle of road infrastructure through connected digital construction. Oke, selamat siang dan terima kasih Pak Rangga.
Selamat
bergabung
siang,
dari Jakarta.
Pak. Selamat siang. Terima kasih atas undangannya.
Good afternoon and thank you for joining us. It's great to have a local perspective on this global technology, showing us how they can be applied right there in the Indonesian context. Okay, quick audio check Pak Rangga.
All right.
All looks good in your end. Please share your screen and begin your presentation.
All right, give me a moment. Okay. Just a bit confirmations. Can you all see my screen?
Yes, great. We
All
see
right.
your screen.
All right, thank you.
So the stage is yours for next 30 minutes.
Okay. Thank you, Pak Novian.
Hmm.
So, thank you again one more time to introduce myself. Rangga Tarunatmaja. I'm based in Jakarta actually, but I'm covering all ASEAN. So I'm supporting in infrastructures, focusing in there, and related to these presentations and this session is about roads and highways. So that's why I put the title of Roadway Project Delivery here. So we are not going only focusing the creating the models, but also focusing on how to deliver the data into your company itself. So I hope by these presentations we can transform your roadway project delivery. We can walk through each phase of the project life cycles. Yeah, not only from specific phase, but I will focus on all of the project life cycles. We can highlight the key milestone, and we can show also how these solutions can bring the real value to your teams and the projects. Okay, so let's discover together how digital innovation is reshaping the infrastructure for a smarter and more connected future. All right, move on to the next slides. But the agenda here for the roadway project delivery, we will use the AEC collections and the Autodesk Construction Clouds. We will take a look at the evolutions of the collections and also the platform. Okay, the project phase and the milestones, and where is this all heading forward. And we as a Autodesk also believe the digital transformations is a critical for our customers, right? For all of us, all of you actually, to achieve the sustainability commitments. And over the last decade was one where technology transformed so much, right? As you can see, from the last decade, especially during COVID, right? The technology grows so much, and between 2010 and 2020, the global data generated went from 2 to 60 zettabytes. It's around, okay, just to give illustrations, 1 zettabyte is around 1 billion terabytes. Okay, so meaning data is now everywhere. Automations can connect the process. Platforms can connect you with your value chain partners and customers and also the communities. Only through the digitally connected processes and data will companies can unlock the ability to achieve and direct their impact. We have to move past assessing and reporting impact after the fact. We also need to virtually the models and simulate and also visualize the impact before it is real, while it is still cost effective to improve our actions. And there's also a fun fact from the IBM. They study with their own titles on your impact, released around several months ago. Interviewed 3,000 CEOs from around the globe. Those CEOs who report deliberately aligning their sustainability and digital transformations effort are realizing substantially higher growth than their peers. Okay, and there's also one report from Autodesk Design and Make released 2025, and past year we also released 2024 versions. Design and Make State of Design and Make report in 2025. You can download. It's for public, by the way. You can download from Autodesk sites. There's also a report. We interview a lot of user expert all around the globe regarding the digital transformations, not only for the AI, we also mentions about the sustainability and also the resource in there. Okay, please just check our sites to download the state of design and make a report. Okay, moving on. In these slides, we'll like to give a moment to reflect on how our industry has evolved. Okay, traditionally, we rely on CAD, the computer-aided designs. Obviously, we create a detailed drawings and plans, while CAD is revolutionized the draftings. It was largely 2D. Okay, this connected process. Then move forward to the BIM, Building Information Modeling, which introduced the intelligent 3D models, right? Not only 3D models, but also intelligent 3D models and data-rich environments. BIM allowed us to visualize, simulate, and coordinate design more effectively, but it was still often limited to isolated teams and also disciplines. It's like a silo. Yeah? So today we are moving into the era of connected BIM. This approach breaks down silos by linking the data, linking the models and workflow across the entire project life cycles. We connected by connected BIM will enable the real-time collaborations between owners, planners, designers, and also contractors. By ensuring everyone works from the same source of truth. It's not just about the better design; it's about smarter project delivery. We can improve the decision making, seamless transition between phase. All right. So the final step is about the future of the infrastructure. Is about fully integrated platform where the data flows effortlessly, enabling the predictive analytics, perhaps the automations, and also sustainability. Okay, by embracing this connected BIM, we are preparing our teams and projects for a future where technology empowers us to deliver a safer, more resilient, and more sustainable infrastructures. At Autodesk, we have both the design tools related to our solution, our value. We have the AEC collections, and there's also the ACC. But we also have the cloud-based platform to make sure every required stakeholders can communicate and collaborate as required on your projects. All right, so this is the AC collections. We have this little bit product hero from Civil 3D, Revit, Recap, InfraWorks, Navis, and Docs. So by showing you these slides, I want to highlight how the AC collection supports every stage of roads and bridge design. Okay, from context modeling and conceptual planning to enhance the decision making with design review and clash detections. And also, finally, to integrate the design authoring for roads, bridge, and intersections. Okay, so with tools like perhaps Civil 3D, Revit, InfraWorks, Navisworks, the teams, your project teams can collaborate and automate your design tasks and ensure the accuracy throughout the project life cycles. Okay, so think of your projects as a living assets. Okay, the asset is not only physical assets. I need to remind everyone here, the data is also an asset. Okay, evolving from plan to design through the build phase into the operation and maintenance. Okay, when we connect the data and workflow across those phases, transformation stop being a buzzword. Okay, that's also a key points in there and becomes everyday practice. Okay, we have the tools like InfraWorks, Navisworks, and so on. You can make the analysis, collaborations, also the optimizations part of the standard flow, while cloud collaborations and content managements will keep everyone working from the same source of truth. Okay, there will be no silos and no guesswork. So there will be no also point fingers in each project, right? And there's also a soft bundles of BIM Collaborate Pro. The teams, the project teams, can get the coordinations muscles they need without the frictions. Okay, let's moving on to the ACC or Autodesk Cloud Transition Clouds. This ACC platform can fit within the project life cycles across the whole platform. So this is how the data is moved from plan to design to build and to operate. And you can see all the lists here. There are functions within the platform in each phase. We will take a closer look at these functions as we move into the project milestones, right? Okay, so you can also see and zoom in what the construction cloud brings to your project teams. Okay, imagine everyone here can imagine empowering builders with seamless field executions and project managements, so everyone can collaborate and delivers on times and on budgets. Estimators can get more accurate takeoffs. BIM experts can improve the constructability and transparency, and every project team members can access the files they need all in one connected platform. Okay, from project management and quality controls to automated class detections and document versionings. ACC, or Autodesk Construction Cloud, keeps your data organized, your workflow streamlines, and your teams in sync. Okay, with dashboard reportings and predictive insights, you are not just tracking progress, you are spotting risks and driving efficiency. This is how the modern constructions gets done smarter, faster, and together. Okay. With each steps of the project life cycles, there is a potential for data loss. Again, I will again mention about the data assets. As the project progresses, this loss can be more and more critical. It was thought that BIM, Building Information Modeling, will be the solutions to data loss, right? The silver bullet. While that is a key part of the solutions, it is not the only factor. Okay, a unified platform where the data is available to the team members during all the phases is critical for the success of a project and helps to avoid the costly loss of information when the data is handed over between personas. For example, the owners to planners and move to the designers and move again to the contractors and back again to the owners, like between the project phase. Okay. Oops. Let's move on here. This is a bit historical story here. Back when 30 years ago, the drawings were digitized, right? Recently, the groups moved into the BIM phase to create a more intelligent models. We all done it. But what is the ultimate goals? It is the data management. Okay, the digitizing design and constructions and providing access to the data-rich assets. Okay, this for today, I think the big topics is about the assets. That's why I mention it frequently. The ACC can accommodate each of these levels of delivery with ultimate goals being end data, rich informations. Okay, so it accommodates the needs of today, but can allow the owners, consultants, contractors, and other stakeholders can integrate and connect together and move to the end goals. Okay. Right, so we can move on to the project milestones. Okay, so we can dive deeper into the phase that are generally several key milestones. Each phase has several key milestones that can be benefit and enhanced using the AC collections and Autodesk Construction Cloud. Okay, here are the handful of milestones examples in a typical roadway projects. Right, from the plans, we can move to the designs and also build, and lastly in the operate phase. Okay, so we can move in the plan phase. Let's look at some of these typical activities. What the purpose and needs. Here, the owners and the planners, of course, will evaluate the traffic needs and projections. They will assess the environmentally sensitive areas and develop alternative for designs. The alternative analysis will help and determine the preferred alignments alternative based on all factors such as environmental impact, asset and performance, public need, and cost-benefit ratios. For examples, these videos here, right? You can see there's a 2-lane, just as examples here. There are 2-lane roads. It connects the freeway interchange from major subdivisions, and it needs to be expanded due to demands, right? The owners and planners will use the traffic simulator in InfraWorks, okay, as a part of the purpose and needs study. They could also identify the environmentally sensitive areas and include them in the studies to aid in the alternative analysis. Different or multiple road configurations can be created in InfraWorks as a concept road. They are displayed in the contextual environments. This design alternative can be stored and accessed within Torres Docs or ACC, where the folder format is set up according to the project needs, right? You can save it as a template, by the way. Additionally, anyone with project access permissions can view the InfraWorks models in the ACC viewer. So project owners don't need to have the InfraWorks access or install in their machines, just access the Autodesk Docs or ACC to view the alternative. Okay, next one is we can dive into the design phase. So the design teams can pull the Esri or ArcGIS data. So the Esri data can get a better pictures of existing conditions, right? The more information they have about the existing conditions, the better the final design products. Okay, from these examples, you can see the existing conditions are collected and detailed in the design phase using the Autodesk connector for ArcGIS. Okay, just in Civil 3D, as you can see in the video, the design team can compile the data layers that can be added to Civil 3D. This provides details about existing conditions for the projects. All right. Once this data has been assembled, design disciplines can share the CAD files and the surface or the terrain with other disciplines using design collaborations module inside ACC, Autodesk Construction Cloud. Here, the survey team is sharing the existing features and the existing ground surface. The other disciplines can consume these share files, and in this case, the civil team, and use them as a reference or base files in their designs. They can preview the files in ACC prior to consuming them. All right. Back to the Civil 3D, the Civil team will consume the base files. Consume means download, by the way. Consume the base files and the surface itself that was shared from the survey team and set them up as XREFs or as data shortcuts. Okay, this file can share and can occur throughout the project life cycles as teams update their design. Okay, and files are automatically updated as they are consumed. All right. Okay, moving on to the detailed design here. As design progress, the design teams can start to develop the plans, the specifications, and estimate. The tools are in place to create the accurate and intelligent design models that can efficiently represent all aspects of the projects. For example, the accurate models with properties data, detailed design for bridge, drainage, utilities, plan sheets, cross sections, quantity takeoffs. Okay, so as you can see in this video over here, the detailed designs can proceed using the Civil 3D, where the roadway alignments, both the horizontal and vertical geometry, can be created and modified. Okay, the roadway assemblies, for example, can also be developed to create the detailed corridor models. The earthworks quantities can be calculated and displayed in the cross sections. All right, designers can use the Dynamo for Civil 3D to run a routine or complex task, like an automations, and add the additional elements to create the complete roadway models. Okay. The engineers can use the tools within the Civil 3D, perhaps the drive functions, to fully inspect their models for any issue. The structural engineers can link the corridor models back in InfraWorks and create a bridge or perhaps a tunnel to determine all the bridge materials, the dimensions, and the parameters. Again, the information is the assets in here. They can take these same models into Revit and where they can review the bridge layout and sections details. They can also fully configure the rebar details. Okay, and these videos, you can also see the plan sheets can be set up and easily maintained in both Civil 3D and Revit. When plan sheets are uploaded to the projects, the Autodesk Construction Cloud will automatically scan the drawings to assign the sheet numbers and titles based on the sheet contents. You can search the text, search text can be added by the users. Okay, sheets can be accessed and reviewed by the project teams in the office or in the field. The sheets and files can be used as reference documents during the design review. Okay, talk about the design review. That's our next topics here. Okay, so by reviewing the designs, doesn't have to be a complicated. Okay, with Autodesk Construction Cloud or with Autodesk Docs, all your project files are centralized in one user-friendly platform. Okay, making the collaboration seamless. You can share, you can view, and you can also annotate the designs in real time. No more scattered feedback or disconnected communications. Whether you're in the office or working remotely, Autodesk Construction Clouds, Autodesk Docs, keep your design review process smooth and efficient. It's to help your team, project teams working together and deliver the better results. Okay, so moving on. Okay, so the next one is with the Autodesk Construction Cloud, the design review process can be a collaborative journey that goes beyond boundaries. Obviously, you can easily access and share the design files. You can allow the team members your own projects to view and annotate with ease. And not only for your internal project team members, you can also send it and share it to the external party, and it will gone are the days you can sort through the emails, WhatsApp for feedback. So we can use this platform as a real-time comments, ensuring the insights will share instantly. Okay, so it can drive a cohesive and dynamic review process, whether you're a part of the internal team or working remotely or working with external party. So ACC can empower you to contribute effectively, making design review a smooth and productive effort. Okay, and here in this video here, we can see how the visual collaborations brings your projects to life, right? So you can bring your own body into the virtual reality in here. With the ACC or Autodesk Docs, your project teams can share and review the models and drawings in image real time. We call it Workshop XR. Okay, this means everyone, not only for the designer, but also the contractors can access the latest visuals. You can provide instant feedback there and keep the project moving forward together. You can also set up a meeting room inside of this platform, by the way. So you can do some meetings, send an invite to other team members here there, and you can set up meetings and do some real-time checking, real life inside of the models. Okay, so it will create the everyone will stay aligned on the project visions. Okay, moving on to the model conditions. Now that the designs has been developed, let's move into the pre-constructions. The metadata, the asset data is added to the design models. Okay, so these informations will be used by the contractors in the field. Okay, for example, in this video here, the engineers and the contractors can coordinate models details to include the variable metadata. All right. The design team can add the pay item data into the corridor and easily extract the summary of quantity. Sorry. This pay item data is shown in the roadway models. Sorry, give me a little bit. Give me a minute. Sorry for that. So this pay item data is shown in the roadway models, either pavements, sidewalks, curbs, and gutter. And those same models, the Civil 3D files can be viewed in the ACC viewer where the same metadata and property set informations can be viewed and documented. Okay, that's the importance of the collaborations. Okay, the next one is if we want to talk about reviewing the construction itself. All the models, either roadway, utilities, drainage, or even the structures, can be brought together in an aggregated models in the cloud. Okay, it can be used or maybe viewed in the field or in the office. Okay, so the Autodesk Construction Cloud will show the object clashes to help the contractor and the designers to determine the issues prior to them becoming an issue in the field. Okay, so you can run the models to evaluate the schedule and construction sequencing. Okay, so in this video, you can see using the model coordination modules inside of ACC can add the insight to the constructability review process. All right. Model, you can view the models and set up the models to review the general or specific model details. The clash detection feature allows the engineers and also the contractors to review any potential conflict. Okay, I will underline the conflicts prior to constructions, thus helping to avoid the costly rework and in-field conflicts. Some of the conflicts can be dismissed as a non-issue, and you can also directly create the issues in the model coordinations. Here, the light poles is in conflict with the drainage pipe. This information is identified as an issue and is reviewed and assigned to the engineers of record. Okay, these Civil 3D files, image and sheet files can be referenced in the issue. You can also reference other photo and video, by the way. Once the design is updated, the engineers can post the updated design models and compare the change to ensure they have been made. Okay. Construction schedules can be added in Navisworks to simulate a 4D build sequence, right? To outline the sequence of construction tasks. Okay, like what we shown in the video over here. So we can move into the field executions. Here in this field, the contractors has an access to the plans, right? And has access, of course, to the files that represent the design intents. The field executions is about designing the execution process, moving from clipboard and inspection form to digital documents, tracking submittals and requests, all of it in one platform, and all of it is in digital. This can bring the field process, digital plans, RFI, field inspections, photo, or also perhaps the progress tracking to the projects that is then made available downstreams. Okay, nothing can be lost in this process. These become a living document with a trackable history. Okay, and you can also put your point clouds into this ACC. All right, so the next one, the contractors, let's say, can create an RFI request for informations to request the project details. Here, the contractors is asking an inspector to look at the culvert identified as a potential issue. All right, the contractors has access to the project files and sheets and can provide the markups and comments on the plan. They can also add image from the field. This information is then assigned to the field inspector who can provide additional details or reference information if needed. Here, this video, he uploads an expansion video of the culvert. Okay, the RFI, because from information, is then assigned to the engineer of record who makes any needed change to plans or models as a result of the RFI. The RFI will track the entire request history and be closed for distributions. So everything can be tracked. All of the historical data can be tracked inside of the platform. You can see all of the historical data in there, not only for the models itself, but also the historical data or the metadata. Okay, that's one of the best, the main key takeaway from this slide.
Excuse me, Mr. Rangga.
Yes, Pak.
You have 3 minutes left for your
Oh,
presentation.
okay. So, I think this is a bit final slide about the project close out. Guess we are running out of time. So, with access to the plans and files, the contractors can also provide the as-built data from the field and note the change on the drawings. Okay, I mentioned this several times already. In this case, the contractors is adding a guardrail and treatment. So you can also leave the comments in the design files and change are based in the field recommendations. These informations can be communicated back to the design team where the updates can be documented. I think I can move to the next slide because this is the most important thing in these slides about the assets delivery. So in these slides, the final aggregated models is delivered to the owner with all the documented change and updates. They now have a comprehensive data set, right? They have been able to track the progress and follow the workflow throughout the projects. Okay, so just for illustrations, in this final phase of operations, the owner has access to all the documents and can aggregate the models created by the design team and the contractors. Specific asset data and property set details can be utilized to provide the more information about the specific project elements. Right here, the model is showing the asset card data for the bridge abutments. This data can be reviewed in InfraWorks, Revit, and in ACC. The final project's details are published to ArcGIS, perhaps, for future access with the same attached metadata. The civil 3D elements like the alignments, feature lines, pipes, cargo points can be accessed inside ArcGIS or S3. Through the ACC and ArcGIS connections, the project files can be accessed and referenced to provide a complete digital twin models. This is one of the options if you want to see the digital twin by using the GeoBeam. So the final models can also reflect the correct geometric details as well as the metadata needed for asset maintenance and operations for the lifespan of infrastructures. Okay, the next options to create the digital twin is by using the Autodesk Platform Service. I guess PU, the Ministry of PU, also using the APS based on their dashboard in beam.pu.go.id. Correct me if I'm wrong. The URL is beam.pu.go.id. You can see it's based on Autodesk Platform Service, and this is one of the examples. It's not from the PU, but I take from the other regions. You can see the highway operations by using this APS. Okay, so by using the APS can enables the teams to capture the photos and access live CCTV feeds directly from the platform because it's open API, right? So it can give the project stakeholders real-time visibility into the site conditions. These integrations of visual data can help to improve the monitoring, safety, and decision-making. Okay, it's making the highway management more efficient, perhaps responsive. As you watch, you can notice how these digital tools can bring together the field data and live imagery, empowering the teams to collaborate and solve challenges, and of course, faster than ever before. Okay, I have this final topic about content catalog, but I guess we have limited timing, so I can just go into nope. Perhaps
1 minute
this.
left, Mr. Rangga.
Okay, fine. Thank you for the reminder. I guess I can just show you this final video. Okay, so this is an illustrations. You can get full pictures of content catalog. Basically how you manage all of the contents, your BIM contents inside of the projects is inside to ACC. So you can use the unified platforms, no need to put everywhere. You can put it inside of your docs or ACC, and you can capture all of the contents inside of this management here. We call it content catalog, right? It can make it will make your company easy to organize your firm's internal BIM content. You can preview the assets with thumbnails and keep track of every versions. So you're always working with the most accurate data. Okay, and you'll see how granular search You can search all of the content, let you find exactly what you need, whether it's a specific family parameters or perhaps the subassembly for the asset types. This means less time searching and more time designing. Okay, that's also one of the key takeaway. The customizable categories and tags can help your team stay organized. You can customize it, and it has the flexible input support of wide range of formats and workflow. Okay, I think that's all for my slides. Thank you very much for joining the sessions. We have explored the Autodesk connected solutions from the plan to operate, from design to constructions, and also the asset management using the APS and also content catalog. So I hope from the Autodesk, on behalf of the Autodesk, you guys can empower your teams, project teams to collaborate, innovate, and deliver better infrastructure projects. Okay, thank you very much. I pass it on to you, Pak.
Thank you,
Okay, all right,
Mr. Rangga, for perfectly illustrating the big picture of connected data management.
all right.
Could you please stop screen sharing now, Mr. Rangga?
Can.
Okay, thank you. A tremendous thank you to all our speakers, Mr. Nathan Kudros, Mr. Rafael Godard, and Mr. Rangga Tarunaatmaja for this incredibly insightful presentation. We have now journeyed from data acquisition and spatial automation through precision standard and mobile mapping to a connected platform that manages this data across the entire asset lifecycle with tools like the Autodesk Construction Cloud. We now move into our 25-minute live Q&A session. We have received many excellent questions from the audience. I will now post selection of this to our panel. As our speaker, Mr. Rafael Godard, have a limited time, I would like the committee to put the first question for Mr. Rafael Godard.
I appreciate. Thank you for your understanding.
Okay, this is the first question to Mr. Rafael Godard from Risa Hazim Zakariansyah, Master Student Airlangga University. Can you read the question, Mr. Rafael?
Yes, I can read it. So mobile, I can read
Okay.
it loud.
Time is yours to answer these questions, please.
Okay, so scan is to action level engineering. What fundamental misunderstanding on systemic gap most often. Yeah, if I understand correctly the questions, it's about the richness of the data. So we are collecting a wealth of information, but we are not extracting, and I fully understand that it's clearly what we call the data leverage gap. And when it comes to that, I agree that there is a lot to do with related to the extracting software. How does it work today? I think now the things are getting better and better. It was mentioned that artificial intelligence is part of the workflow that we are implementing as well in this journey. I don't know if it was clear during my presentation, but I shared this point cloud classifications, which helps to put the data into layers and helping the team to focus directly on the area of interest. So that are kind of improvement that we are bringing to the market to first focusing on what data is important for the project.
Okay, that's excellent.
And helping in the faster.
Okay, thank you, Mr. Rafael Godard, for your explanations. For the next questions, perhaps for the Dr. Nathan Kudros. Okay, this is for Mr. Piambodo from Hutama Karya. As of today, there's an ongoing debate between Tesla and Waymo. I think you can read directly, Mr. Nathan Kudros, yeah?
Yeah, just give me a few seconds and I'll digest it. Well, making a choice between technologies. I try to avoid that. I mean, I've advocate a combination of. That's the beauty mobile mapping from where it's not just a laser scan. You've got cameras, both directional cameras, 360 cameras, and we use radar for below the road surface. I mean, I'd like to get away from choosing a technology and trying to use them all. If you need to make choices, well, there's constraints on the project, what your budget is, speed. There's a whole number of choices around that, around making the right choice. But if companies like Tesla and Waymo, they'll have these multi-billion-dollar budgets. If they're looking at these systems, you want to drive as many as you can out of it. Certainly, the costs of some of these, I don't know whether much lower end LiDAR is coming on the market. Raphael could tell us more because it's a bit cheaper than what he's putting to the market too around some of these little chip pieces, but I just don't know what they can do. But if we can get costs down and we can get the data automated, then we can do more of that. So I wouldn't want to see that choice. If I was to choose between LiDAR and imagery, LiDAR gives you better geometry, and so therefore better geometry around potholes and rutting. Image gives you a better level of detail, so that'll give you things like cracking. So if you need to make some choices, those are some of the choices you can make. Thank you.
Thank you, Mr. Nathan Kudrus. Just depend on the situation, yeah, the answer, yeah. So next question for Mr. Trangga Tarunaatmaja from Billy, the researchers. Please, Mr. Rangga.
Okay, so for a team that has just started collecting digital data, but still relying on traditional 2D drawing separate spreadsheet for management, what is the first most manageable step they can take to move toward connected BIM workflow using the AC collection without overwhelming their team? Okay, there's a bit sensitive words in there, overwhelming their team. Okay, so obviously move from 2D drawings into the BIM. That's the first obvious steps. Or also I can say it's a foundational step. Obviously, if you want to get all of the properties, all of the informations, you need to move from 2D into the BIM. Not only 3D, but BIM, yeah. Because inside of the BIM, with the information modules, there's an I in there, informations. Not to make everyone's overwhelmed. Okay, you can focus first on the 3D part in there, and step by steps, slowly, you can add on the informations inside of your BIM models in there. Okay, I think that's the most logically steps that your teams can have right now. Mr. Billy, thank you very much for the questions, by the way.
Thank you, Mr. Rangga, for your explanations. So next other question for Mr. Rafael Godard again. Committee, yeah. So this from Ms. Ida from ITB. For a large-scale province-wide road inventory project, what's the practical implementation strategy? Would you recommend a centralized mobile mapping team covering the entire area, or is it more effective to equip multiple regional offices with the technology? What are the key logistical considerations? This is the question, Mr. Rafael Godard. Please.
Thank you for the questions. Actually, I mean, it's all about how frequently and how challenging are the connections between the different provinces. As I mentioned during my presentations, our mobile mapping solutions can capture hundreds of kilometers per day, and we have multiple customers doing this exercise successfully. But this said, so you could imagine, okay, maybe one solution is enough. I can cover my whole country with one solution, but it would be occupied every day, capturing every day. If you want to be more efficient, maybe it would be wiser to have a distributed solutions around your region. But again, here I would really be happy to discuss more in detail with you about this demand, because it's really depending on how complex are the connection between the different regions and what kind of network we are talking about, just to tailor exactly the solution that will fit your need.
Okay.
And the key logistical consideration are more or less, I would say, based on how efficient and easy it is to travel, to commute between the different regions. I know in Indonesia, you have these different islands, so it can be sometimes complicated and not efficient. So this needs to be considered definitely.
Okay, thank you. So we need more discussion about this thing, yeah, Mr. Rafael Godard, to find the clear answer for this question.
Thank you.
Okay. The next question for Mr. Nathan Kudros. So this is from Francisco Cahaya School. First question, what is the scalability of the bridge site solution? Can it be applied to bridges of all sizes and types? And what is the typical implementation timeline and cost for a new bridge? And the second, I think, can you provide example of the clear, consistent, and comprehensive output that are generated? How does this workflow integrate with existing bridge management system? So two questions from Francisco Cahaya School. Please, Mr.
Yeah.
Nathan.
Yeah, that's good. I mean, all of these technologies and digital technologies need to be scalable across all sorts of assets too. But we've created 4 tiers of this solution, and they have different costs and different equipment associated with it, and it can be applied to different bridges depending on the size of the bridge and the type of the bridge. So the first is a comprehensive solution that we kind of nicknamed the platinum-based solution, which is flying a drone around it. But also, drones are not the best for capturing the deck when there's live traffic on there. So if you have got walking systems or vehicle-based systems, then you want to capture the deck with that. The next tier down would be the gold, and where we've used autonomous drones that can actually fly closer to the bridge than a standard drone to pick up more detailed imagery around those sorts of things. We've got a silver solution that is more of a standard-based drone, so you'll get a lower resolution mesh, and the bronze-based solution, which is where you can't fly. So there'll be some bridges and types of bridges where you can't fly with this, and where you might use something like a point cloud solution with an OmniSlam or some of these sorts of solutions around it to pick up point clouds, and then you can measure geometry from. You won't get detailed imagery. So it's a combination of those things. Typically, a lot of these captures you can do in under a day with these digital solutions and around this with sufficient planning. And then it's a matter of processing the data and uploading it associated with that. So there's a reasonable cost in doing it at the moment, and why we're targeting this, we're targeting it at not all bridges, but where the value is in the bridges where you need complex infrastructure to actually do that inspection, or you can't get to easily. So where there's a barge, elevated work platform, and other sorts of things. In terms of outputs that are generated, well, we want to take it further than just the insight. So at the moment, what I've focused on is rather than just the point cloud, and I have been talking a lot about the insight, and the insight's really important, but I want to get to the report, because I think these days the insight and the digital data isn't enough. People actually need a report in the current system. So we've been taking that further into automated reporting so that you can actually still get a PDF out the back of it, but you can trace that back through the digital platform about where that came from. So we can generate a PDF as well as the spatial outputs, whether it's technically like different file formats, whether it's Esri file formats or more open source or JSONs and those sorts of things. So in terms of workflow management systems and asset management systems piece, there's different ways you can do that. The simplest way is a simple export-import. So you can export a GeoJSON from ours or a database and ingest that into another system or even an Excel spreadsheet. The more complex way is actually to have a live connections between different systems. We don't try to do that too often, and that can take a lot of time to do. So there's a quick overview in answering those questions.
Okay. Thank you, Mr. Nathan Kudros. That's really great. The next question for Mr. Rangga. So from Mr. Iksan, SPJI, the handover from construction to operation is a critical failure point for data. How does the Autodesk Construction Cloud specifically facilitate a smoother, more reliable data handover to ensure that as-built model received by the asset owner is accurate and rich with the necessary information for future maintenance?
Okay,
Please, Mr. Rangga.
Okay, thank you, Pak Novias. Thank you, Pak Isan, for the questions. Okay, the obvious answer for that is you need from not only from the constructions or the designers, but also the owners needs to be in the same hub inside of your ACC. Okay, if we talk about the Autodesk Construction Cloud, the owners, all of the participants in there is need to be inside of the one hub. So by using the asset tools inside of the Autodesk build modules from the ACC, you can easily transfer your data into the owner side. So that's also the part of the I guess that's also part of the requirements from the ISO 19650, right? So you can also read and learn from the ISO to create the best way for the management data inside of your project itself. Okay, again, let me repeat it. All of the project stakeholders will need inside of the one hub, one projects, so you can turn on, turn off, or hide and use the project assets models to hand overing your data to the owners. Okay, I think that's the quick answers right now, and I will happily talk more regarding this in offline. Thank you, Pak Isan.
Thank you, Mr. Rangga. Collaboration is the key,
Yes,
as summarized.
correct.
And then the next question again for Mr. Rafael Godard, please. Okay, from Atika, SPGI. Rafael, your presentation highlighted the critical importance of data that meets global standard. How do you balance the need for this high-level precision, which we assume comes with a higher initial cost, against the budget constraint of a typical local government? And what is the long-term cost of not investing in these precisions? It's a really good question. It's for you, Rafael Godard. Please.
Yeah, I fully. Very good questions indeed, definitely. It is a matter of fact that mobile mapping solutions are quite costly solutions, definitely. But we should balance this cost on the volume of data and the quality of data that we are capturing. Because investing in, I would say, low budget solutions will always bring to low quality data, and in the end will not bring the good results or the good information that will lead to the best informed decision for the road maintenance. So in the end, it will be a loss, a waste of money. So that's why I know it's a high budget, but it's worth it because on the long term, the cost is absolutely absorbed by all the benefits the precision of the system can bring, and the quality of the data can also bring for the decision-making process.
Okay, great. Thank you, Mr. Rafael Godard. Next question.
I am sorry, I need to leave. And I say goodbye. I'm sorry.
Okay. Before you leave, Mr. Rafael Godard, I just want one question for you. Yeah. So I need what is the one advice, a piece of advice you would give to a local government agency just starting its digital asset management journey?
Oh, the one advice is well, maybe to knock at the door at Horeca supplier. We can organize some demonstrations and check how we could move on with our solutions. Just to I would say explain and show how we could implement that as well in your setup. We need to know how is your organization set up, not only also your IT infrastructure, all this kind of information that help us to tailor the solution in the most efficient way. So that would be my approach here. Checking with you directly and discussing together, being on the same table and explaining all the things together.
Okay. Thank you, Mr. Rafael. Once again, big applause for Mr. Rafael Godard. You can leave the session. Appreciate for your time.
Thank you very much. Thank you very much. My best regards to everyone. Thank you. Bye-bye.
Yeah. So we continue with the next question for Mr. Nathan Kudros. This is from Anton Hutamakarya. You mentioned that successful automation requires a deep understanding of real-world processes. Beyond the technology itself, what are the first steps an organization should take to redesign its traditional inspection and data management workflow to integrate a tool like roadside effectively? So, for you, Mr.
Again,
Nathan?
I like that because this person really took a good point out of what I tried to get in my talk before. It's really around use case and where the maximum value is. I don't think enough people the main problem you're trying to solve and the use case that you're trying to solve through that problem. So don't try to do everything. because you'll get completely lost in it. You need to what you can win and make some benefits nice and early in a quick win. So that might be something like road failures is the key thing, or maybe it's cracking, or maybe it's crash incidents from roadside barriers or vegetation. Whatever it is, pick something to start with that you think is achievable, and then work through that, but identify the value to the organization. So what's the benefit to the organization? Because if you don't get that benefit early, your program won't continue. So you need to get a nice benefit from whatever you initially start with, and then build your business case from there, and it'll start to grow from that point. So that's my piece of advice, is spend more time identifying the exact problem you want to solve before launching into it straight away.
Okay, thank you, Mr. Nathan Kudrus. So start small, yeah, but really take impact for the organization. So not start
Right.
in full scale directly. That's great. Question also for me, same. What is the one piece of advice you will give to a local government agency just starting its digital asset management journey? So from your side, please.
It's probably not too dissimilar from what I just answered around there. It's what benefit are you going to get from this? Is your I always say, like, technology is always there. The technology thing, I mean, it might seem complex, but I would say it's relatively easy. I'm in that technology, but I find the people space is a lot more difficult. So even if you solve this problem, I've seen many digital journeys stop because the people don't really want it. They don't really want to change. They don't really want to use it. So you need to bring people along for that journey, involve them so that they see the benefits and step them through that process. So you've got use cases and value that you need to provide. Then you've got the people and the journey that you need to bring across it. And then you've got the technology piece that you will solve with that. You can't leave any of those aspects alone. So make sure you're touching on all of them and have activities and tasks on all of those, so you bring it all together, because if you work on one and not the other, it won't work and you won't get to where you need to be.
Okay, that's great. I like your advice. Thank you, Mr. Nathan Kudrus. So for the next question for the Mr. Rangga. Okay, this is from Aulia from Hutama Karya. For an agency that has started collecting data, digital data, but still rely on traditional 2D drawings and separate spreadsheet for management, what is the first most manageable step they can take to move toward a connected BIM workflow using the AEC collection without overwhelming their teams?
I believe I've answered these questions already.
I think you already answered this question, yeah?
Yes, correct, in the first question.
So maybe just my question the same, yeah, because
Okay,
I want the advice also from you, Mr. Rangga. What is the one piece advice you will give to local government agency just starting its digital asset management journey? So because this is really from different perspective, we want to hear also from you, Mr. Rangga. Thank you, please.
Okay, so thanks for the questions. I believe never ever have silo mindsets. That's the one key takeaway. So collaborate more and don't shy to learn to every stakeholders or other parties outside of Indonesia. That's a good way to learn the best practice of all over the globes. Perhaps echoing what Nathan Kudrus also said, start small, and from that you can move along continuously from there. Yeah, just consistently do the digital transformations, especially in the constructions. I think that's all, Panof. Yes.
Okay, thank you, Mr. Rangga. Great.
Okay.
We still actually have a lot of questions, but unfortunately, yeah, that's all the time we have for question today. We must now bring this very productive Q&A session to a close. On behalf of the Indonesian Road Development Association and our speakers, I thank you for the high quality question from our participants. To conclude this presentation session, allow me to summarize a few key takeaways from today's webinar, now enriched with our speakers' insight. First, visibility is the foundations. We must start with accurate data. Geospatial intelligence, as shown by Ferris using tools like roadside, bridge sites, and photo navigator, is the critical first step to close the information gap, enabling everything from virtual to proactive route mapping. And second, precisions enable trust. Data must be reliable. Global standard and precision capture, as demonstrated by Leica Geosystem using mobile mapping solution, MMS, are what allow us to confidently measure key indicators like IRI and PCI, moving us from reactive to predictive maintenance. And third, connection unlocks value. Data must flow. Connected digital construction, as explained by Autodesk, using the AEC collections and Autodesk Construction Cloud, is the essential framework that prevents data loss and allow information to create value across the entire asset lifecycle, from planning to operations. And the last, automation drive efficiency. As Dr. Nathan Kudrus saw, spatial automation combining AI, analytic, and rule-based workflow is a key to shifting from labor-intensive reactive method to scalable, proactive planning and maintenance. By adopting this integrated digital solution, we can move towards a smarter, more efficient, and more sustainable management of Indonesia's road assets. The journey is continuous one, built on accurate data, trusted standard, and seamless collaborations. I want to extend my deepest gratitude to our inspiring opening speaker, Dr. Engineer Hedi Rahardian, MSc, and to our three exceptional experts, Dr. Nathan Kudrus, Mr. Rafael Godard, and Mr. Rangga Taruna Atmaja, for generously sharing their knowledge and vision. A special thank you to the Indonesian Road Development Association for hosting this pivotal event. To all of you, our participants, thank you for your time and engagement. Presentation material from the speakers will be shared with you along with your certificate by the committee of this event. We hope this session has provided you with valuable insight to drive innovation in your own organizations. I will now return the flow of the event to the MC for the official closing remarks by the Secretary General of Indonesia Road Development Associations. Once again, I am Novias Nurendra. Thank you for your attention.
Thank you so much for Mr. Novendra as our moderator, and thank you to all the speakers and to our outstanding moderator for exploring today's topic in depth and providing valuable insights on digital solution for smarter road asset management, which align with the theme of today's webinars. Okay, ladies and gentlemen, and of today's event and wrapping up all the topic discussed previously, let us now listen to the closing remarks. Committee, please play the video. Okay, we will now hear the closing speech from Insinyur Hedi Rohandi Aga MA as General Secretary of Himpunan Pengembangan Jalan Indonesia or HPJI to Mr. Hedi Rohandi. The floor is yours.
Okay, thank you very much for giving me a speech, a closing remark for this event. First of all, I would like to thank for the three speakers. I think it is very good presentation for them, and also for Novias who lead this discussion for efficiently and effectively for us. There are some. I think this seminar has presented very highly qualified speakers and also experts who lead into deeper perceptions and as well as the broader insight for digital solution in the future. Highly appreciation for our resources persons and as well as to the company who are supporting this seminar. But I think there are maybe two words that is special I noted for speakers. The one is that we create the futures, right? I think it is very important for us because the future is not any, but we can create what are going to do in the future. The second one is that because we are talking about the data, and then data is never stop and never still that always changes. Then we have to. I heard from the speakers as well. The word is data is a kind of living data, so we have to work with that. So it means that two words are very surprising to me because in the future there will be some changes and also we have to create on that. Notice that how the digitalization and its environments leads to guarantee our road infrastructures, the quality as well as the sustainability, because we have to think about that. We are not living now, but we have to think, we have to lead, we have to give some other for our future generation. And the next is that we talk about tools, we talk about models, we talk about the application. So it means that all the tools and appreciation are readily available. Now the rest is that how to use that, how to implement that, and then it will, because the rest is our commitments to implement and in our real works on practical experiences. Again, I would like to thank for the speakers as well as moderators and also our supporting staff, supporting companies who make this event successfully. Officially, we close this seminar. Thank you very much. Good afternoon, everyone.
Okay, thank you, Mr. Hedi, for your closing remarks and for officially closing today's webinar. We hope that the insights shared the webinar will inspire meaningful contribution toward advising Indonesian road infrastructure management to digitalization transformation, making it smarter, more efficient, and sustainable. Okay, ladies and gentlemen, we have now reached the final part of our program. Before we summarize, allow me to announce the winner of today's Best Participant Awards. Get ready, everyone. And committee, please display the name.